Introduction. In general, the specific gravity Gs of a material represents the ratio of the mass of a given volume of that material at a temperature to the mass of an equal volume of distilled water at the same temperature. Gs at T degrees Celsius is equal to weight of a given volume of material at T degrees Celsius divided by weight of same volume of water at T degrees Celsius. However, for geotechnical engineering purpose, the specific gravity of swells are usually reported for water temperature at 20 degrees Celsius. Gs at 20 degrees Celsius is equal to weight of a given volume of material at T degrees Celsius divided by weight of same volume of water at 20 degrees Celsius. From this basic definition, specific gravity can be obtained from different formulas such as Gs at 20 degrees Celsius is equal to weight of unit volume of soil at T degrees Celsius divided by weight of unit volume of water at 20 degrees Celsius. If the specific gravity of soil for water temperature T degrees Celsius is known, then it can be converted to the specific gravity for water temperature 20 degrees Celsius as follows. Gs at 20 degrees Celsius is equal to weight of unit volume of soil at T degrees Celsius divided by weight of unit volume of water at 20 degrees Celsius. It is usually determined by the principle of displacement of water by soil in a density bottle, volumetric flask, pycnometer or a gas jar. Table 2.1 shows you typical values of specific gravity or soil. Table 2.2 shows you specific gravity of water at different temperature. Scope of the test. This test is performed to determine the specific gravity of soil by using a pycnometer. Specific gravity is the ratio of unit weight of soil at a stated temperature to the unit weight of same volume of gas-free distilled water at a stated temperature. Equipment: pycnometer, volumetric bottle. Balance: 0.01 gram sensitivity, distilled water, drying oven, desiccator, vacuum score optional, funnel, thermometer, pipette or medicine dropper, spoon, etc. Significance: specific gravity of a soil is used in the phase relationship, soil density calculation. Test procedure: A. Pycnometer calibration, theoretical procedure. Points for the calibration curve can be obtained by substituting different temperatures in the following equation. B. Specific gravity determination. 1. For cohesionless soil. 1. Put about 150 gram of oven dry soil into pycnometer without losing any soil grains, which is already half full of de-aired distilled water. 2. Remove all of the air which is entrapped in the soil by 10 minutes. Accompany the boiling with continuous agitation. 3. Cool the bottle and suspension to some temperature within the range of the calibration curve for the bottle. 4. Add water to bring the bottom of the meniscus to the calibration mark. 5. Dry the outside of the bottle and the inside of the neck above the meniscus. 6. Weigh the bottle with water and soil in it to 0.01 gram. 7. After checking to be sure that the contents of the bottle are at uniform temperature, record the temperature. 2. For cohesive soil. 1. Work a sample of the soil to be tested into a smooth paste by mixing it with distilled water. The sample used should contain approximately 50 gram in dry weight. 2. Pour the paste into a calibrated pycnometer. 3. Remove the entrapped air, cool and obtain the weight and temperature as was done in steps 2 to 7 of the procedure for the cohesionless soil. 4. Pour the entire mixture of the soil and water into a large evaporating dish of known weight. 5. Dry the soil in the oven, cool and wet. From this, the dry weight of the soil grains can be obtained. Alternative procedure. 1. Determine and record the weight of the empty, clean and dry pycnometer. 2. Place 50 gram of a dry soil sample passed through the sieve number 10 in the pycnometer. Determine and record the weight of the pycnometer containing the dry soil. 3. Add distilled water to fill about half to 3/4 of the pycnometer. Soak the sample for 10 minutes. 4. Apply a partial vacuum to the content for 10 minutes to remove the entrapped air. 5. Stop the vacuum and carefully remove the vacuum line from pycnometer. 6. Fill the pycnometer with distilled water to mark. Clean the exterior surface of the pycnometer with a clean dry cloth. Determine the weight of the pycnometer and contents. 7. Empty the pycnometer and clean it. Then fill it with distilled water only. To the mark, clean the exterior surface of the pycnometer with a clean dry cloth. Determine the weight of the pycnometer and distilled water. 8. Empty the pycnometer and clean it. Sample calculation. Here M1 is equal to weight of pycnometer, M2 is equal to weight of pycnometer plus soil, M3 is equal to weight of pycnometer plus soil plus water, M4 is equal to weight of water plus pycnometer, GT is equal to specific gravity of distilled water if normal tap water is used. Figure 2.1 shows you A. Weight a blank pycnometer. B. Fill the pycnometer with 50 grams soil, take weight. C. Fill the pycnometer with water up to the mark along with soil and use vacuum pump to remove voids. D. Taking weight of soil and water with pycnometer. D. Fill the pycnometer with only water up to the mark and take weight.